G'day, how's it all going? I'm Dr. Philip Button from the Food Microbiology Academy, and a very warm welcome to you, wherever you are watching this in the world. This is our third session of our 5-part series on HACCP and GMP, and it's great to have you along. So I'll share my screen and let's take a look at what we're in for this session. So last session, we left off with monitoring of critical limits. So when the critical limits deviate, there's a loss of control, and I use the pasteurizer approach. If that temperature of that pasteurizer drops down from 72 degrees, then the monitoring needs to ensure that it is being able to catch that, basically. So if we do have a loss of control, a deviation from that critical limit, what next? What happens then? So corrective actions. So these are procedures that need to be followed when a deviation occurs. So we need to isolate, hold the product for safety evaluation, because if you think that the critical limit of 72 degrees for 15 seconds is the temperature that does eliminate, theoretically, pathogens from milk. But if it drops down to 71 degrees, well, it could actually enable some to survive. So that's why we need to isolate, hold the product, do some micro testing, and ensure that it is actually safe, or actually discard the product. So that's why we need to divert the affected product or ingredients to another line where the deviation would not be considered critical. Sorry, I'll just go back and say that the two ways of doing addressing the product, and that's what I'm trying to say. Two ways of addressing the product. G'day, I'm Dr. Philip Button from the Food Microbiology Academy, and a very warm welcome to you wherever you happen to be watching in the world. This is our third session in our 5-part series on HACCP and GMP. So it's great to have you along, and let's get started. Let's get stuck into it. So I'll share my screen, and then we shall go through the material. Corrective actions. So in our last session, session number 2, we gave the example of, in talking about monitoring of critical limits, we gave the example of a pasteurizer which is meant to operate at 72 degrees for 15 seconds. So that's the critical limit. But what happens if it actually drops down to 71 degrees? Well, we need to ensure that we know when that happens. So that's why we need monitoring of the critical control points. But when that happens, then we need to take corrective actions. So corrective actions are procedures that need to be followed when a deviation occurs. So what are those procedures? What can we actually do when we have that deviation? 4 things that could be done. Isolate and hold that product for safety evaluation. So we can take that product out of circulation as soon as it's been produced, do some safety evaluation, so like microbiological testing, for example, then see if it is actually safe to use. Because theoretically, if we're reducing the temperature, then there should be survival of pathogens, or to some extent. So this microbiological testing will be able to assess whether the product is in fact safe to release. We could divert the affected product. This is another way. or ingredients to another line where the deviation would not be considered critical. So this means, for example, just say that we have, using the E. coli 0157H7 example again, we could divert the milk to be used in manufacture of a product which might have a subsequent thermal processing step, which would therefore eliminate that particular pathogen. We could reprocess if the product will allow, from a sensory quality perspective, or the worst case scenario is to actually destroy the product, which you don't want to do, because that's the financial losses in that will be could be quite substantial. So what we need to do, basically, corrective actions are there so that we can correct and eliminate the cause, and basically restore process control. So bring that critical control limit back under control. So if we've got 72 degrees for 15 seconds as the critical limit for a pasteurizer, if it drops down to 71 degrees, then we need to bring that critical control point up to the critical limit of 72 degrees. And not only that, but we need to, second point, determine the cause of that deviation so that we ensure that there's no future reoccurrence. Secondly, it's vital to identify the product that was produced during that process deviation and then work out what are we actually going to do with it. So those 4 steps that I showed in the previous slide are what we need to do. Then, once we've restored control, so restored the critical control limit, then it's important to have verification to ensure that the system, under normal circumstances, or once control has been restored, is operating according to the plan. So that's when verification procedures, which will have a level of confidence that the HACCP plan is based on solid scientific principles, it's being followed, it's adequate for the hazards associated with that product and process. So that's basically what you want the verification process to do. And that means validating and verifying the various critical control point activities. So calibrating the monitoring devices that you are using to monitor that particular temperature of the pasteurizer, calibrating the review records, the sampling and testing regime, ensuring, just double checking that you're sampling correctly, you're testing correctly for the right parameters, and reviewing the records that you're having for that monitoring of the critical control point. Then overall, verifying the HACCP system by observations, reviews, microbiological end product testing, and then involving regulatory agencies and ensuring that what you're doing, the limits that you're working within, are actually still valid for the various regulatory agencies, which they can change from time to time, of course, the types of limits or safety margins of error that they recommend. Lastly, then, we've got record keeping. So record keeping for ensuring that your HACCP plan and supporting documentation that you're using, records of your critical control point monitoring, records that your corrective action and your verification activities. So just like any quality process, just like anything really, it's absolutely critical that you have good record keeping, so that if there's a problem, something goes wrong, you need to be audited, or whatever the case might be, everything is in order, everything is monitored and recorded properly, so that you can just say, yep, here they all are, everything is in order. So that's the step. Those are all the steps for HACCP, which is summarized here, where we analyze the hazards, determine the critical control points, then establish limits for those critical control points, then the next step is to monitor those critical control points and establish the procedures if those are deviated. So if there's loss of control there, then we need to bring those limits back to the critical control limits. And what are the actions that we need to do? Then verification procedures to ensure that they have been brought back and that the HACCP system is generally working overall well, and establish a record keeping system. That is a perfect summary, therefore, of all of the steps in HACCP. While food safety hazards are very prominent, and most of what I will be talking about in the 4th and the 5th series are all to do with microbiological hazards, what I wanted to cover now, though, is physical hazards, just basically the other sorts of hazards. So these are any potentially harmful extraneous matter that, is not normally found in food. So things like glass and wood and stones and metal and plastic. So these can come from the actual processing environment. They could come from the agricultural environment and make their way through the process. And they can come from equipment. They can come from operators, which is another reason why it's good to have robotic processing, things like that. So these are the physical hazards that you could find in food, and you can see that these are pretty serious. Metal and stones and things like that are really serious physical hazards. Now, a few slides on chemical hazards. Mycotoxins, as there's a few slides here on natural chemical hazards. So mycotoxins, which are secondary metabolites of fungi, are a real problem. And aflatoxins are amongst the most carcinogenic, and they're produced by Aspergillus species. Temperature and water activity really varies quite widely, and because of that, they're really difficult to eliminate, and especially because they occur in and on a really wide variety range of foods. And the way they, their carcinogenic potential is because of their nucleic acid binding. And so, there's been studies done which show that they've got that there's liver cancer has happened in animals because of that. And so how can we stop that? So there are some biological flavor bacterium, for example. My work on aflatoxin contaminated foods as an example of biological controls. Now, paralytic shellfish poisoning comes from shellfish and is really pretty serious indeed. So there's 18 toxins, for example, and these are from contaminated molluscan shellfish, which are feeding on algae. Now, these are, as you can see, the range tropical to temperate waters worldwide that covers a substantial portion of the world's fishing grounds. And it's just so serious. Look at the symptoms: numbness, burning or tingling sensation on the lips and tongue, which spread to the whole face and the fingertips. And then you've got lack of muscle coordination in the arms, legs, and back. And so this is just really serious. And it's really important to be aware of this and be applying these particular controls, such as molluscan shellfish that's been obtained from approved waters. So these approved waters have been found to be safe for obtaining these shellfish from, because otherwise the conditions in those particular areas, other particular areas that are not safe, are actually likely, or much more likely, to result in shellfish which have the potential to contain these toxins. And that is where we shall leave it this particular time. So with that, I'm going to stop my screen sharing here. And thank you very much. Thank you all very much for attending our third session. It's an absolute pleasure here to take you through HACCP and GMP, and I look forward to finishing off the chemical hazards part next time and then starting on the microbiological hazards. So thank you, and yeah, it's been our absolute pleasure. Dr. Philip Button signing off. I'm from Food Microbiology Academy, and I'll see you next time. See you around. Cheers.